How exactly are blocks created in a proof of work ecosystem like Bitcoin? For the longest time, we all know that miners have to perform cryptographic puzzles or hash puzzles for them to be able to mine a block. But how exactly does this happen? So in this video, we're going to be discussing that, and we're also going to be writing things out for you to really understand how this thing works. So for me to explain the cryptographic puzzle that these miners have to go through, I need to explain something known as hashing. So hashing is a one-way function, a one-way algorithm where you give it any amount of input and then it gives you a definite output. So for Bitcoin, it uses the hash function SHA-256. So when you give it any amount of input, it gives you a 256-bit number as your output. And one thing about hash functions is that they are deterministic, which simply means that when you give them a particular input, it will give you the same output all the time as long as the input remains the same. When you change a tiny bit of the input, it results into a drastic difference in the output. And again, you can't get or even guess your input from the output because they totally look different. And again, no two inputs gives you the same output. No two different inputs gives you the same output. As long as the input is different, it gives you a different output. And as long as it remains the same, it gives you the same input, right? So these are the features that makes hash functions very powerful. You're going to see it play out in the use of mining. So how does the blockchain work? Blockchain is called blockchain because these are blocks and they are chained together. So let's take Bitcoin blockchain for example. So we have, let's say we have here the Genesis block, and then Genesis block was the first block on Bitcoin, and then there has been a lot of blocks, like a lot of blocks. So let's say we have those blocks linked together within this space, and then we now have a current block now, and this current block is currently full, and then we need the miners to solve this puzzle for them to generate a new block for us. So let's call this block parent block, right? So one thing about blocks is that it has something called block header. Just see it as the summary of whatever that is going on in that particular block. And you find properties like the timestamp, you find properties like the parent hash, you find properties like the block number, you find the nonce. So there are a lot of other things. You find the Meku roots there, you find the receipt roots and all of that. We are not interested in all of that today. So the two things we are interested in a particular block header is the parent hash and the nonce, right? So what is basically a parent hash? Remember that every block has block header. So for a particular block, it needs to have the hash of the previous block, and that is what is entered in the current block as the parent hash. So let's say we want to get a new block here, right? So the parent hash of this new block will be the block header. This block header now, we will get the hash of this block header. It will be our parent hash. So this will be equal to the hash of this block header, right? That's what we are going to have in this parent hash of this block that we're trying to create. So inside here now, also in the block header of this one, we have what we call nonce, right? So this nonce is just a random number, and it's just what the miners have to keep changing for them to meet a criteria. So when creating a block, there's something called a difficulty criteria. So this is a criteria that the hash that the miners is solving for would meet. So once they produce a hash that meets that criteria, then they are able to publish it to the blockchain for it to get accepted on the blockchain. So this criteria is always like, we need a hash that starts with 2 zeros. right? We need a hash that starts with 2 zeros, right? So when a particular miner solves for this hash and gets a hash that has 2 zeros, then they can now publish it to the blockchain if they are the first. So this is a competition. So one person gets to do it first. Once you get it, you publish it and it gets accepted. Then if you didn't get it, then you wait for the next puzzle to come up. So this block difficulty, it can be increased or reduced, right? So if the criteria is requiring like a lower number of zeros, then the block difficulty is like lower. But then when it's requiring like, let's say 5 zeros, that means they have to do more work for them to produce a hash that meets this criteria. So where this criteria is being adjusted is like Bitcoin takes like 10 minutes for them to generate new block, right? So in a case where the miners are generating blocks in 5 minutes, that means they are solving it too fast. That means there's need for them to increase the difficulty for solving a block. So when they increase it to like 5, then they can maintain like that approximate of 10 minutes to create new blocks. But when the miners are solving it in like 15 minutes, that means it's too hard. They have to reduce the difficulty. Let's say they now bring it back to 2 zeros, right? So let's say the miners are now solving for a hash that just has 2 zeros. So what do they exactly do? So the computation they have to do for a huge number of time is they get the block header of this particular, this is a model because they're trying to solve for this block. So they have to have a model that they prefill. They have all the other guys, they have the timestamp and all of the other things. So they get the block header of this their model. They just have to perform a hash of the block header of this their model, right? Which is block header plus the nouns. Let's say they are starting with a nouns of, let's say 200, right? Plus their 200, right? It gives them an output. Let's say the output started with 5, 6. It doesn't meet this criteria. It started with 5, 6, not 0, 0. So what these miners have to do is that they have to perform this computation over and over and over again. I remember what we are considering here is 256 bits numbers, right? So that's quite a lot of numbers. So they have to do this for probably trillion times for them to be able to get a hash that meets this criteria. That's why in Bitcoin you need a lot of energy for you to be able to do this, because you have to run heavy computers for you to run a capacity that will be able to go through this iteration. It's basically a trial and error process, and you have to have a very good computer that has a huge capacity for you to be able to do this like up to 1 trillion times. Right, so this is basically what these miners have to do for them to solve for a block, and in turn they get rewarded for solving for this block because they are spending energy to solve for this. So this is basically what goes on in the Bitcoin ecosystem for miners to be able to generate blocks, and then for the blockchain to keep expanding, and then for continuity, the blocks get linked to each other as it goes. So I believe this basically explains what happens in the block creation of ecosystems like Bitcoin. So subsequently, we're going to be discussing that of Ethereum post-merge and also for Stacknet. So stay tuned. And this is Amarachi Ugwu. And until next time, peace out. Bye.